In this video, we're going to talk about basic integration techniques. Integration in JC is broken down into quite a few parts. The first one is actually doing the integration. Questions would be just like this kind. Nothing very fancy, just ask you to differentiate it. No application whatsoever. And in that part, integration techniques, you are required to know quite a few things. Your basic fractional stuff, and then you have integration by parts, and of course integration via substitution, and integration of parametric equations. These four are just integration techniques, no application yet. Okay, so the application part comes in the second half of integration, which will require you to into volume and area. So all this require prior knowledge of all this. So we're going to take a look at just one part in this video. This one, integration of fractions. I'm going to assume that most of you are comfortable with integrating basic stuff like 6x plus 2. We're not going to dive into that. I'm also assuming that you're comfortable with things like x squared, and then if you have 4x cubed plus 2 to the power of 7, you know that the differentiation of the inside is 12x squared, right? So you need to top up with a 12 and immediately divide by the 12 such that this is in the form of f prime x, fx to the power of 7, which will give you 1 over 12 fx to the power of 8 over 8, which is just 4x cubed plus 2 to the power of 8. So I'm assuming you are already good with this. Let's talk about fractions. Every time you are required to solve integration of fractions, just follow this flowchart. First question, ask yourself, is it proper or improper? If it's improper, this means that the top is of a higher degree than the bottom. For example, x cubed, blah, blah, blah. Here you have x minus 1. What you do now is you apply partial fractions until you get proper fraction. Once you have done with that, you are required to integrate that proper fraction. So there are three cases. First of all, ask yourself whether you can use this. Integrate f prime x over fx to the power of whatsoever. Are you able to use this? If you sort of can, for example, take a look at this, 1 minus 4x minus x squared, right? Differentiating the content would give you negative 2x minus 4. Take a look at the top. Looks similar, but you have to do something about it. So if you sort of can, force it and make it happen. We'll dive deeper into this part later on when we attempt this question. And then once you're done with this, you still cannot solve, then take a look whether you can do this, which would give rise to ln of fx. And if you still cannot do, then you do this b part 1, b part 2. Part 3 of our flowchart will be to complete the square. There is no way you will run into questions that you can't do this, can't do this, can't do this, can't do this, because this will give you this trigo inverse results. Actually, all of this, you can apply it to this part sometimes when you run into a more complicated substitution questions. Let's go ahead and actually do the first question. So let's take a look at this. This is clearly a fraction, right? And they ask you to integrate a fraction. So let's go back to the flowchart. Proper and improper. This is proper. Can we use partial fractions? Yes, because this is a clear case of partial fractions here. This will become something over 2x minus 1 plus something over x minus 1 square plus something over x minus 1. You have to have 2x minus 1 because this is power 2. You have to have itself and lower powers of it. Continuing on, this will give us 6x squared plus x plus 2 is equals to a times x minus 1 squared plus b times 2x minus 1 plus c times 1 copy of x minus 1 and 1 copy of 2x minus 1. Let x be 1. This will be gone. This will be gone. So 1b would just be 6 plus 1 plus b will be 9. So this was my first value, 9. Second of all, let x be half. This will be gone. This will be gone. Half minus 1 will give you 1/4 a equals to 6/4 plus half plus 2. So therefore a would just be 6 plus 2 plus 8, which gives us 16. So now C, we will just let x equals to 0. This side will give us 2. This will be 0 minus 1. 1 times 16 plus 0, negative b, which is negative 9. This will be 0, so plus c times negative 1 times negative 1. This will give us just c. So therefore c is negative 5. So putting these values back in, you will get 6x squared plus x plus 2 over 2x minus 1, x minus 1 squared. Split it up into 3 pieces, 16 over 2x minus 1 plus 9 over x minus 1 squared minus 5 over x minus 1 dx. Split it up into 3 more integrations. It will give me this, 1 over 2x minus 1 plus 9 over 1 square minus 5, 1 over x minus 1 dx. Here, we will make use of ln. So to turn this into a 2, because there will be the differentiation on the bottom, you will need to borrow from the 16. So this will give you 8 ln 2x minus 1. The second one, because power is negative 2, meaning you can turn this to x minus 1 power negative 2, this would just be f prime x in front, which is just 1, times fx to the power of negative 2. This will give you 9 x minus 1 to the power of negative 1 over new power. This, because it's power 1, once again we have to make use of ln. Differentiation on the bottom is just 1, it's already on top. So this is in the perfect form for ln fx. Simplifying this will give us 8 ln 2x minus 1 minus 9 over x minus 1 minus 5 ln x minus 1 plus c. That's it for the first part, rather easy after you have done the partial fraction. Take a look at this. Let's try to use our flowchart and see whether it works. So the first one, proper or improper? This is definitely proper. And can we use partial fractions? I'm afraid this is sort of stuck, am I right? Because there is you can't break this up into 2 nice brackets at the bottom. So if we can't do that, can we use here? If it's proper, can we use this? F prime x over fx to the power of n. Like we said at the beginning of this lesson, that you sort of can. Let's take a look how. Because this can be written as this, 6 plus 2x over 1 minus 4x minus x squared to the power of half, right? This part, when you differentiate it, you actually get minus 2x minus 4. Can we force the top to look like that? Yes, you can. Applying a negative on the outside and negative on the inside, so you're not changing anything. That's my first step. After that, you realize that this is like that, minus 6 minus 2x over 1 minus 4x minus x squared, power half. This sort of looks like that, but not really. To do that, we have to split the 6 into 2 pieces, into a negative 4 and a negative 2. So this will look like that, negative 4 minus 2 minus 2x. I'm going to collect this and this to give us this. Split into 2, minus, plus, negative 2, which is this lonesome guy, over the same fraction. After that, what we do is, this entire first part, you can use integration of f prime x, fx to the power of n. N in this case is negative half. So let's go ahead and just solve this integration. You should get 1 minus 4x minus x squared to the power of positive half over half, which would give us 2. First part done. Now the next part is rather difficult. Take a look at this. This is still not integrated. So you have negative, negative, give us positive, right? 2 over 1 minus 4x minus x squared power half. Take a look at this. Revisit the flowchart. Can you partial fractions it? No, you cannot. Is this in this form? Differentiating the inside will give you negative 2x minus 4. There's no way you can top up with x here. Is it the third form? Is it f prime x over fx? Sadly, it is not, because this is not power 1 at the denominator. So of course, final desperation attempt, you'll be using complete the square, and let's see what happens from then. Let's take a look at this, just this item, 1 minus 4x minus x squared. Let's try to complete the square. We'll rewrite it as this. And then completing this will give us x plus 2 whole thing square minus away 4. Expanding this will give us x plus 2 whole thing square plus 4 plus 1, which is plus 5. Rewriting this will give us 5 minus x plus 2 whole thing square. I'm going to replace this thing here by this. You see something nice. So this would be integrating of 2 over square root 5 minus x plus 2 whole thing square. Suddenly, this becomes a lot nicer. Once you go to the MF26 here, let me just scroll down. You realize that it resembles this form the best. Can you see that here? Of course, we can just bring out the 2. And this resembles this. So integrating this will just give us 2 sine inverse. X in this case is x plus 2. Just make sure you do a check. Once you differentiate x plus 2, does it give you 1? If yes, then you can go ahead. If let's say there is a 2 here, upstairs have to be a 2. Okay, but in this case, this is just 1. So you are safe to write x plus 2 over a. In this case, a is root 5. So the final answer is just, oops, I left out a negative here because this is this. Negative is still on the outside. So the final answer is just negative 2, 1 minus 4x minus x squared power half plus 2 sine inverse x plus 2 over root 5 plus c.